Thank you, DigitalFUTURES, for honoring me with this award. I'm truly humbled. My personal story as an Iraqi woman who was forced out of her ancestors' homeland because of violence, only to find a global audience to her ideas, is nothing short of remarkable. I'm immensely grateful to all the people and places that helped me be here today. I'd like to extend this honor to Robert McNeil and Associates for taking a chance on me very early on and for their incredible vision, insisting on excellence and community, for providing a safe and fertile ground for many brilliant ideas to flourish and take hold. Most importantly, I think the real reason why PanelingTools is honored today is because of our passionate users who have been relentless in their criticism of our work throughout the years, and for occasionally reminding us how it changed their own lives. In hopes of inspiring minds more creative than mine, please allow me to share a small slice of my journey with PanelingTools and how it came to be. I have a background in both architecture and engineering, and have always been fascinated with tools as conduits for creative expression. When I understood the creative design process as a reflective flow between the mind and the product, it became clear to me that the medium should facilitate an unobstructed flow between the designer and their creations. My curiosity about digital tools started some 23 years ago when I was a graduate student at Auckland University in New Zealand, looking into digital methods available at the time and how intuitive it was to create pattern concepts. It was clear that these tools were not designed with the creative design process in mind. The whole concept of paneling and pattern generation was dismissed as a detail to be added later in the form of textures. Using these tools did not support paneling as a starting point of any design concept. The realization that no good tools were available to help creative design started me on a road to learn how to write software, and later conceived a digital tool to create paneling solutions from concept to fabrication. For any creative design tool to be successful, they need to satisfy 4 requirements. They need to be useful. That is, they fill a gap or solve a problem. They need to be intuitive, easy to use, and fast to create with. They also need to be reflective. That is, easy to edit creations and instantly see the result. Finally, they need to be affordable. They have to be easy to find and access. There are abundance of patterns in nature and strong mental image in designers' minds about how they look and how they ought to look in their designs. But the problem is that they are time-consuming to express using any design medium. They are very time-consuming to edit and recreate, and it's really hard to build complex paneling solutions using traditional technologies. Many things changed in the past couple decades. Fabrication technologies shattered the barrier of paneling complexity and its affordability in building design. Yet, there was no medium available that supported designing complex paneling solutions that also communicated well with fabrication. Paneling tools for Rhino and Grasshopper simply filled that gap with an intuitive digital tool that is easy to use, edit, and access. It became an essential part of the designer's digital toolkit, whether to create a concept, communicate it, or build it. When I first started the PanelingTools project, I had 2 goals in mind. The first is to support a quick mock-up of paneling ideas, and the second was to be able to prototype the concepts into physical reality, making a smooth transition from design to fabrication. At first, I did not have a clear idea about the specific flow or functionality. I only had a concept of a tool that was itself uncertain, and I used a reflective process to create it. It meant that I needed to involve the end users very early in the process. PanelingTools development followed a path very similar to that of any other creative design project. It started with a problem to solve, synthesized a concept prototype, then shared it with others for feedback. I actively listened to the user suggestions, but most importantly, tried very hard to understand the workflow and what they like to achieve. I weeded out undesired features and redesigned the flow and functionality multiple times. The work did involve many more cycles of prototyping, reflection, refinement, and full partnership with the users. Over time, PanelingTools started to shape into a useful general tool to release. We documented the features, examples, and workflows, and shared it with the community. It is important to stress that I was afforded to develop PanelingTools using this reflective cycle because there was a community of willing users to work with, and because I had access to a digital platform that was stable, open, and powerful. My designer background helped me internalize the uncertain nature of design, and my rigorous software training meant that I could build the tools without having to articulate any specifications. When trying to develop a pattern concept, designers start with either an inspiration or a process. The initial inspiration can be a picture, a terrain, a form, some flow, a scale, a pattern, or some other elements. Instant preview meant that the designers can reflect on their creation in real time. PanelingTools uses a two-step solution: grid first, then panel. This gives maximum flexibility to develop paneling ideas intuitively. The grid helps set the flow and the scale quickly using various methods. Paneling patterns can be conceived out of connecting grid points, but also can be predefined modules. The output of panels can be in any geometry format. Designers can pick the one that is useful for the particular stage of design. At early stages of design, users can quickly synthesize their concepts with lightweight geometry. Once the concept matures, the tool allows creating more detailed panels on the expense of heavier models and slower feedback. Detailed panels can be made ready for fabrication through unrolling for laser cutting or turned into meshes for 3D printing. To give you an idea how paneling is actually built in practice, I'd like to share with you the paneling process in the movie Terminator Genesis. The set designer Andrew Reeder used PanelingTools to develop and then build his paneling concept. He started with an atmosphere, a feel of space, but also took it all the way to fabrication. When building the actual set, the 3D models were passed to the contractor. It was in a mesh format. The contractor attempted to orient all panels to a flat surface, then projected the outlines to create the document for laser cutting. He quickly realized that this would be a very time-consuming process and asked for an alternative format. Since all panels were originally developed from 2D paneling grids, it was trivial to also provide the 2D panels ready to unroll for fabrication. The final set was a combination of physical and digital parts augmented to create continuous space. What started as an idea and experiment became a popular tool used everywhere, not just in architecture, but also in other design professions and during all stages of design and building. Thank you all.